Hello, I'm Stuart Waters with Hart Machine Tool. I'm going to show you how to set up the TKF1500 and use it on your metal. The first thing you want to do, everything's adjusted with a 17mm wrench and a 6mm Allen. Those come with the machine. First thing you'll do is you'll walk up to it and you'll set the angle of the bevel. You can see the notches here from 20 degrees to 55 degrees. You'll see a separate notch right here for 37.5. All the welders need that number. Today we're doing 45, which is what you asked for. So you'll do the 17, you'll loosen this up, you'll slide the head. There's two 17mm on either side. Once you've done that, you'll go and you'll adjust the amount of takeoff using this cam. You're able to move the cam back and forth. The cam has numbers on the side from 0 to 8. Of course, we'll be running all the way up because you want to do maximum takeoff. Maximum takeoff is 0.6 inches on the machine. No matter how thick of metal you're beveling, maximum is 0.6. The size that you talked about was over 2 inches. You'll need the adapter block. This block goes in right here. You'll take the Allen out. You'll attach the block with the longer bolt, and this will go up to 80mm, from 40 to 80mm, a little over 3 inches. So you'll definitely need one of these in your operation. This is a special order piece. We keep these in stock. This is the thickest piece of metal I have. I think this is 1.5 inches. So we're just going to go ahead and run that today. Once we've gone and set the cam, tighten it down, and we'll check the thickness. You want it to be able to slide through. Small parts, you will mount the tool to the table using a workstation, or you can use the threaded hole on the bottom of the machine. This threaded hole will be used on the workstation. The handles will come off. These are 17s again. When you're using it on plate, you'll run the tool like this, using the wheel. When it's small parts, you'll mount the tool on the table and run the small parts through it. The tool weighs 35 pounds. When I'm operating the tool, when I'm finished with a part, I take the tool and I lay it to the side, or I put it on a roll around cart. I do not pick the tool up and down off the floor. You just wear yourself out that way. It's much easier to just immediately put it on the next piece of work. This is the 2-speed. You don't need the 2-speed. The 2-speed is for stainless. It has this additional gearbox right here. First gear and second gear. First is the slower, second is the faster speed. Of course, on mild steel we run at 5.5 feet a minute. We always leave it on the second speed. You won't need that, and it increases weight, more cost. Like I said, if you're going to mount this on the table, you're going to take both the handles off. Okay, you can cut it. These are the stainless steel punches. They are laser marked. This is the wearing line. This is the line in which you're not supposed to go past. The mild steel do not have any marks. The stainless ones have the serial number, part number, and the wear line. One thing we haven't talked about is the amount of takeoff. We have to have a land for the punch to push against on the very edge. We can actually bring this down almost to within 1/8, but we cannot have a knife blade. If we have a knife blade, it'll roll the metal over and it'll look like an alligator teeth. So we always have to have a land, some amount of land. I could bring this in a lot more, but just showing you on this piece. We discussed the reasons for using the stainless steel punches. This is mill side. This is 65,000 tensile strength. This is flame cut. We don't know how heat treated this got, so it's best to run the stainless steel punch on all the mild steel. The handle is a 2-speed switch. It's the trigger and the safety switch. The safety switch also is important because when we're running small parts, it has to have the trigger on continuously, hands-free. So it's a 2-speed, it's a 2-position switch to lock the tool in and let it continuously run. So the heat is transferred to the chips. So I'm able to actually operate the tool without even wearing gloves. Obviously you should wear gloves because you know, for safety. But the heat, there's no heat. So this is still 65,000 tensile strength. We haven't heated this any way. Thank you. You're ready. One other thing I didn't mention, you can also do a lot of pipe beveling with this tool. Of course, the pipe has to fit in between the part here, and you can just rotate the small parts. So I think it's about a 3.5-inch minimum size pipe. Most of the operators are doing 12-inch. You can see there where the pipe would fit in, and they rotate the pipe holding the tool. We do a lot of Schedule 80, 12-inch, tends to be the size pipe and larger. Also do a lot of stainless steel pipe.